welcome to Family Feud. I'm your host, George Harvey, and today we've got another great one for you. This time we'll be playing for a lesson with Mrs. Williams. Let's meet our two teams. From Elk Grove, we have the Bravo Gals, Annie and Caitlin. And all the way from Alabama, we have the LuKrembo men, George and Lex. Let's start round one. Give me Lex and give me Caitlin. Alright, top three answers on the board. Name a major technique for solving quadratics.
Factoring, George.
Is that on the scoreboard? Would you like to pass or play?
Go pass it, George.
Alright.
Now we're going to identify our A, B, and C. Next, we're going to use our diamond method on the side. So first, on top goes A times C. So 4 times 9 is 36. And our B is negative 12. Now what two numbers multiplied together equals 36 and added together equals negative 12? We do negative 6 times negative 6. Let's check. Negative 6 times negative 6 is 36. And negative 6 plus negative 6 equals negative 12. After finding the two factors, rewrite negative 12x. Next, we're going to factor by grouping. So group the first two terms and then the last two terms. Now looking at 4x squared minus 6x, is there a greatest common factor? Yes, we can factor out a 2x. And then looking at negative 6x plus 9, is there a greatest common factor? Yes, we can factor out a negative 3. Keep in mind that you want your factors within the parentheses to be the same. Essentially, you can factor out in 2 minus 3. 2x minus 3 comes from here, the parentheses, and then the 2x minus 3. Now set each factor equal to 0, so we're going to add 3 to both sides. And then we're going to divide by 2, so x equals 3 over 2. Because it is also 2x minus 3, our other solution is also x equals 3 over 2. Because x equals 3 over 2 twice, our answer must include the term double. Therefore, our solution is x equals 3 over 2 double.
Alright, Annie, there are two more answers on the board. Name a major technique for solving quadratics.
Square root method.
Is it on the board?
We're going to explore how to use the difference of squares in solving quadratics. Substitute y for 0. Remember that your goal is to try to get x by itself. So our first step is to add 10 to both sides. Our next step is to cancel out the exponent of 2. So we're going to square root both sides. Now remember, we're trying to get x by itself. So next we're going to subtract 4 from each side. So our exact solution is negative 4 plus or minus the square root of 10. And for our approximate solution, plug it into the calculator. So our approximate answer is x is approximately negative 7.162 or x is approximately negative 0.837.
Alright, Caitlin, name a major technique for solving quadratics.
The quadratic formula.
The what?
The quadratic formula. Roll the clip. Once again, we're going to identify our A, B, and C. Next, we're going to write down the quadratic formula, which is negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, substituting our a, b, and c into the quadratic formula, we get negative 10 plus or minus the square root of 10 squared minus 4 times negative 3 times 2 all over 2 times negative 3. Simplify. So I get negative 10 plus or minus the square root of 124 all over negative 6. Notice how it says plus or minus, so you're going to be inputting two equations into your calculator. And here is our exact and approximate solution.
Oh, now I remember. That's what a baby parabolas drink, the quadratic formula. Alright, now let's look at the scoreboard. Alright, moving on to round 2. Give me Annie and give me George. What are the different natures of roots in the discriminant analysis and what is its relation to a graph?
Negative, and this will mean that there are two imaginary roots. On the graph, there will be two complex solutions, which means there will be no x-intercepts.
Would you like to pass or play?
We would like to play, George.
Alright, Caitlin, we have two answers on the board. What are the different natures of roots in the discriminant analysis and what is its relation to the graph?
Infinity. There would be an infinite amount of solutions.
Let's check the scoreboard. I'm sorry for your loss. Alright, Annie, there are still 2 answers on the board. What are the different natures of roots in the discriminant analysis, and what is its relation to the graph?
Positive with 2 real roots. This means that there will be 2 x-intercepts on the graph.
Is that correct? Wow, good job, Annie. Okay, Caitlin, there's one more answer left on the board and you only have 1 strike. What are the different natures of roots in the discriminant analysis, and what is its relation to the graph?
This one's easy. It's a triple root with an inflection point on the graph.
Is it on the board? Yikes. Sorry, but that was the incorrect answer. Alright, Annie, there's still 1 answer left on the board, but you have 2 strikes, meaning that if you get this question wrong, this will go to the discriminant. What are the different natures of roots in the discriminant analysis and its relation to a graph?
I think I know this one. I remember it in class, but
I'm sorry, but you are out of time. Well, that last round seemed to be a parabola. Let's move on to the discriminant. Alright, Lex. Your family has a chance of going to sudden death if you get this answer correct. What are the different natures of roots in the discriminant analysis, and what is its relation to the graph?
0. On the graph, there will be a double root, and there will be 1 real solution.
Alright, is it on the scoreboard? Alright, to summarize the discriminant analysis, the discriminant is b squared minus 4ac. And with the discriminant analysis, we can predict how many solutions there are and the types of solutions in the quadratic. If the discriminant is greater than 0, there are a total of 2 real solutions with 2 x-intercepts, making it positive. And an example would look like this. If the discriminant is equal to 0, there are 1 real solution with 1 x-intercept. And an example would look like this. And if the discriminant is less than 0, there are 2 imaginary solutions with 0 real solutions. There are a total of 0 x-intercepts, and an example would look like this.
Hi Family Feud watchers, sorry for this interruption. We are experiencing some technical difficulties on stage right now, so please enjoy this episode of Producer Break where we show you how to graph quadratics. Let's take a look at an example problem. Here we have y equals 2 times x minus 1 squared minus 8. To find the key point, we must determine the values of h and k. So in this case, 1 would equal to h and negative 8 would equal to k. We should also keep in mind that a in this problem is equal to 2, meaning that when we graph it, the graph will have a stretch of 2. Now moving on, in order to find our y-intercept, we're going to plug in 0 for the value of x. Okay, as we can see here, y is equal to negative 6, meaning our y-intercept is equal to 0, negative 6. Now to find our zeros, we will plug in 0 for the value of y and solve. Here, after we have solved, we now have our x values, which is 3 and negative 1. Now let's fill out a table of values so that we can graph our quadratic. First, let's put our vertex in the middle, and then we're going to go up 2 values and down 2 values. Now that we have this, plug these x values into this original equation to find the y value. Now that we have filled out our table of values, we can now graph our quadratic. So the domain for this graph would be x is an element of the reals because our graph has arrows on it, meaning that it will go up for infinity, meaning that all the x values on the x-axis will be a part of this domain. For the range, it will be hard bracket negative 8 to positive infinity because it starts here at negative 8, which is included, and will go up positive for infinity. And as for end behavior, as x is headed towards negative infinity, f of x is headed towards positive infinity, and for right end behavior, as x is headed towards positive infinity, f of x is also headed towards positive infinity. Where on the graph it is positive. As we can see, this section right here and this section right here is positive. So our positive interval will be x is an element of negative infinity to negative 1, union 3 to positive infinity. For the negative, we will look on the graph to see where it is negative. We can see that this bottom portion right here is negative, so for our negative interval, it will be x is an element of negative 1 to 3. Now to find our increasing interval, we will look to see on the graph where the slope is positive, and we can see that over here it is positive, meaning that our increasing interval is going to be from 1 to positive infinity. And as for our decreasing interval, we will look to see on a graph where it has a negative slope, and we can see that it is right here, meaning that our decreasing interval will be from negative infinity to positive 1.
Welcome back, everybody. And right now, the scores are currently tied, and whoever wins this round will get a free lesson with Mrs. Williams. So now let's move on to sudden death. All right, now give me Caitlin and give me Lex. All right, this is the final round and this is the final question. What formula do we use for the vertical motion?
H of t equals negative 16t squared plus vt plus s, where v is the velocity and s is the starting position. Boom.
Is it on the scoreboard? And that was the correct answer. Congratulations to Team Parabagals for winning the game. They have won a free lesson with Mrs. Williams.
No, they won.
Lex throws a ball at Caitlin from a starting height of 5 feet above the ground with an initial velocity of 25 feet per second. As Caitlin so quickly said in the competition, the formula for vertical motion is h of t equals negative 16t squared plus vt plus s. From the situation, we can see that v equals 25 and s equals 5. We can substitute that into the quadratic equation to get h of t equals negative 16t squared plus 25t plus 5. When does the ball reach its maximum height, and what is that maximum height? To find that, we need to find the vertex of the graph. We can start by using the formula t equals negative b over 2a. Substituting those values, we get negative 25 over 32, which is equal to negative 25 over 32. And that is about 0.781. We can substitute that time into the equation to find the maximum height, which is about 14.766 feet. So at time 0.781 seconds, the ball reaches its maximum height of about 14.766 feet. When does the ball reach the ground? We can start by substituting h of t with 0, since there is no height at the ground. That leaves a quadratic equation that we can solve with either factoring or the quadratic formula. This equation is not factorable, so we'll substitute a, b, and c into the quadratic formula. Putting that in a calculator, you get two possible answers, negative 0.179 or 1.742. But time cannot be negative, so this is the only right answer. The ball hits the ground at about 1.742 seconds.